this session, we'll be hearing from Floyd on polysemy, learning mapping to line mappings.
Can everyone hear me? Great. So traditionally we think about the task of learning words as learning a mapping between a form and a concept. But oftentimes words map onto multiple concepts. And if we try to understand the meaning of a word like cat as a definition over these exemplars, we actually end up with meanings that both under-specify and over-predict. So let me show you what I mean by that. So let's say that the meaning is a round thing that covers, that fits tightly, and that it's only as big as your head. That would predict that all three of these things would be called caps, and they're not. So that's called a lid, that's a cork, and that's something else, but I would be really surprised if I heard anyone call that a cap. That's sort of the first thing I think of. And this, at the same time, you lose giant mushroom cat because it's too large, and cap and trade programs because they're not really covering anything below them. So definition tells you that these are caps and that these are not, when in reality it's the exact reverse. So we probably don't want to just do away with these exemplars, we probably want to keep them. And this is especially true because many polysemous meanings actually extend on multiple dimensions that don't share very much apparently, but we have to, that's what we experience. So for example, I can talk about a pit in someone's backyard, and I can talk about orchestra pits and armpits, and those seem like shape extensions. And I can talk about fire pits and trading pits, and the shape extension seems to hold again. But critically, I have to have experienced all of these to know that pit can be used in these cases. And even more critically, I can learn an entirely new dimension on which this meaning is extended. And in this case, it would be function. So both of these things are called fire pits. Even though they would more aptly, maybe described as fire bowls or fire plates, that is what they're called, right? And it's not because they're impressions on a plane, but because they share a function, right? And we can't possibly know all of this unless we rely on our experience with these exemplars. But then we have to ask whether these exemplars, learning these specific exemplars, is actually enough. Will that give us all that we need when it comes to this kind of complex word meaning? Because there's another type of phenomenon called homophony, where word forms also have multiple mappings, and yet they seem qualitatively different, right? In the case of cat, there's some overlap and some set of relationships between the exemplars, whereas homophones really just seem like different meanings that have the same label. And obviously these two have different names, so right, the related meanings are called polysemy, the unrelated ones are called ambiguity, homophony, or homonymy. And there's already a little bit of evidence that homophones are tricky to learn. So compared to learning just novel words generally, children kind of resist these meanings. That's from Case and Heiser 2005. And we also know that only about 4% of words across all languages are homophonous, whereas just within English, about 40% of words are polysemous. That's a conservative estimate. And because these words seem different from one another, we wanted to think about whether this difference could present in learning. What does this mean for learning the meaning of words? So we're going to look at two main theories of word learning to see what they have to say about this. So the first is called pursuit, and the second is called cross-situational word learning. So first, pursuit is a hypothesis testing model, which means it limits things. So it picks a mapping out of a scene, right? It's not mapping to everything that it sees. And this is, if you're familiar with Lila Weidman's proposed but verify, it's an adaptation of this, so a recent update. So if you had a naming event like cap, and in this scene you use a strong intentional cue, and you maybe would get the correct referent, and maybe this happens to be a highly frequent referent, so you would strengthen that meaning. And then you'd eventually encounter a scene where your existing meaning is disconfirmed. You see a bottle cap and you think that the meaning is a baseball cap. So you would select one new meaning and actually decrement the disconfirmed one. And if you're trying to learn the meaning of a homophonous word like that, you would do the exact same thing, right? So you would strengthen and then decrement. So this model does bring us to possible word meanings. It gets the multiple exemplars. But what's also clear is that it makes no distinction between how a polysemous form would be learned and a homophonous form would be learned. These look exactly the same in representation. There's no difference in how these were learned. So we can also look at cross-situational word learning to see what it has to say about polysemy. So on this account, co-occurrence of all possible reference would be tracked across many instances. And again, and these types of models can take into account the reference that already have labels, right? So you would get to a case where you have these multiple possible examples or these multiple possible reference. But again, the meanings look exactly the same between these two, right? There's no difference in how they were learned. It doesn't look like there's a difference in their representations. So the question I'm going to ask today, which has never actually been asked, is whether human learning shows difference between these two, right? Because it seems likely that learners could use overlap in similarity or features and get a boost from exemplars that relate in the case of polysemy, whereas the inability to form useful generalizations and homophony would not give you this advantage. So it's a really simple prediction that learning polysemy should be easier than learning ambiguity. So we designed a novel word learning experiment to test this, where participants would either learn meanings that have related features, like these. So here you can see that two of the meanings share the long orange handle, and two share the square fuzzy sponge thing. And this learning will be compared to learning meanings that don't have these related features. And participants will be we're learning these among sets of 5 foils in each. And in this experiment, the ambiguous items were constructed from the same targets, but scrambled across the sets, right? So they were scrambled to really create dissimilar sets, or less similar sets. So a polysymous exposure would look like the video I'm about to show you. Each video taught participants 2 words, and they're interlinked. So that's what you're going to see.
This is a kaisi. This is a nona. This is a kaisi. This is a nona. This is a kaisi. This is a nona. This is a kaisi. This is a nona.
Okay, so in both conditions, as you guys probably noticed, one of the items is presented twice from each word, and the other 2 are presented once. And participants have to learn 4 words across 2 videos, and each word has 3 meanings. So at test, they would see this and be prompted to select 3 kaisis. These 3. And so the results I'm showing you on the y-axis, average score out of 3 possible correct mappings, or correct targets they could have selected, averaged over the 4 trials, and the dotted line is chance. So you can see these are adults. You can see they're well above chance in both conditions. They're just doing significantly better in polysemy. If you're curious, we got these significance values by using mixed models because we have repeated measures. And you might be wondering whether participants learn the word label, right? So we tested a second group of participants, and they got the same exposure videos, like the one that I showed you, but at test they were prompted with a label and had to distinguish the correct target from the 3 other labeled targets, right, that were also targets of other labels. So I'm showing you, again, on the y-axis is the average scores, and the dotted line is chance. So they're above chance in both conditions, and they're doing significantly better in polysemy. But we really wanted to understand whether learning these complex meanings would actually happen at the time in life where you're learning a lot of words. So we wanted to look across development. So we recruited 60 children to participate in the grouping task that I showed you. And since nobody has actually ever run this kind of study before, we chose a wide age range, so that was between 5 and 12 years, but we had an average around 7 years old. And because of concerns about properly age matching children across conditions, and vocabulary matching them, and concerns about power, we tested each child on both conditions. So they would learn the labels for these stimuli, these polysymous ones, and they would learn from an entirely different stimulus set, form word labels. So again, in this experiment, children had to learn 8 words, and each word had 3 targets that they had to distinguish from foils. So it's a lot. So again, I'm showing the mean score, or mean performance in average over the 8 trials. So again, all children in both conditions are significantly above chance, and they're better in polysemy. But a criticism of experiments that show that distributed learning like this is possible, that you can learn multiple referents across many, many instances and track all of them, is that that kind of knowledge doesn't last over time, right? It's a fleeting effect in the lab. So we brought a bunch of the kids back after a week. And again, they're doing really well. So on the x-axis is time point. So there's really no difference between the 2 weeks. The only thing that really seems to drop is the ambiguity knowledge, which is interesting. So to conclude, is there a polysemy advantage in learning? Adults definitely have it. Kids have it, and it lasts a week. And in terms of future work, we're really interested in building this into theories. So like I showed you, there's not a lot of room in existing theories to show how learning polysymous words could even be possible, let alone explaining it. Right, so we're really interested in building a theory that actually capitalizes on this overlap the same way that children and adults do. And to get out what mechanism actually supports these relationships between meanings, we're actually running the same grouping task with ASD children. And the reason we're doing that is because ASD children tend to be more discriminatory about category membership based off of perceptual features. So this is called enhanced perceptual discrimination. And so we're expecting to see an attenuated polysemy advantage in that case, even if they're matched on learning ambiguity or multiple unrelated things. Yeah, so thank you. Thanks to my advisors and my RAs. Definitely have time for questions. Oh, yeah, you prefer that? Okay, great.
Yeah, both questions are all in the second.